Okay, good day class. So for this video we will be discussing the derivatives of algebraic functions. These derivatives of algebraic functions formulas were derived from the four-step differentiation process that was discussed last meeting. And there are basically 9 formulas for us to remember and to be familiar with, because we will be using it to solve for derivatives of algebraic functions. Okay, so the first formula that we need to consider or to remember is the derivative of a constant c with respect to a variable x is equal to 0. This is the first formula for derivatives of algebraic functions. Now, why is this so? We have, recalling the concept of derivatives, we have discussed that it is talking about the change in the value of one quantity with respect to the change in the value of another quantity. For example, you have derivative of y with respect to x. This is talking about the change in the value of y due to the change in the value of x. So one way or the other or another, the change in one value will affect the value of the other quantity in the same function. So let us continue. So, if for example you have a function y is equal to 3, if you are asked for the derivative of y with respect to x, this is also called y prime. Derivative of y with respect to x, the change in y with respect to the change in x is also called y prime. Now, if you are asked for the value of y prime, this is equal to the derivative of 3 with respect to the same variable x. Derivative of y derivative of y with respect to x, okay, is equal to y prime, that is equal to the derivative of 3 with respect to x. Take note that if you are taking the derivative with respect to one variable, you must be consistent with the other part of your function. Take note here, we take the derivative of y with respect to x. For this part, we are also taking the derivative of the constant with respect to x. Continuing, since this is a constant, we can say that the derivative of y with respect to x or y prime is just equal to 0. That is the easiest formula for the derivatives of algebraic function. Number 2, the derivative of u plus v minus w with respect to x. Take note that u, v, and w here are different functions. So, similar with the limits, we can equate this to the derivative of u with respect to x. Of course, you copy the sign or the operation This is positive. Derivative of v with respect to x minus the derivative of w with respect to x. So that is the second part. You can give examples later on. The third is the derivative of u multiplied, the dot here represents multiplication, v with respect to x. For this one, this is equal to u. Take note that these two are different functions. U times the derivative of v with respect to x. Plus v times the derivative of u with respect to, again, x. That is the second formula for the derivative of multiplication, or derivative of two functions being multiplied. The fourth one is the derivative of c multiplied by v with respect to, again, x. Take note that c here is a constant and v is a function or a variable. This is equal to, we can apply the property number 3. You copy the first part, that is c, multiplied by the derivative of v with respect to x, and that is positive for multiplication, v times the derivative of c with respect to x. But again, from the first formula, you will observe here, the derivative of a constant, again, with respect to any variable is equal to 0. So this is simply equal to 0. So any value multiplied by 0 is equal to 0. Except, of course, infinity. Because that is indeterminate. Infinity times 0 is indeterminate. This is equal to 0. So we are left with c times the derivative of v with respect to x. That is the fourth property that you need to consider. The fifth would be the derivative of u divided by v with respect to the variable x. And for this one, this is equal to this time v times the derivative of u with respect to x minus u times the derivative of v with respect to x. This is divided by v squared. That is the fifth. The sixth would be derivative of a constant divided by a function with respect to x using the property number 5. Copy the denominator, multiply by the derivative of the numerator with respect to the variable you are considering, minus the numerator times the derivative of the denominator b with respect to x. Divide this by v squared. And again, since the derivative of a constant with respect to any variable is 0, this will cancel to 0, leaving us with negative c derivative of v with respect to x. This would be divided by v squared. That is the sixth property. Moving on, let's have the seventh formula that we need to consider. This would be the power derivative of u raised to n. And here is a constant value. This is with respect to x. For this one, we copy the exponent n, bring down the exponent rather, copy the base u, and the exponent now will be n minus 1. Multiply this by the derivative of the base with respect to the variable you are considering. This is the power derivative of an exponent. The 8 would be derivative of x with respect to itself. I forgot this actually. It should be number 2. It's okay. The derivative of a variable with respect to itself is equal to 1, and the last one would be the derivative of square root of u with respect to x. Now take note that you can write this as the derivative of u raised to 1/2 divided by the derivative of x. Square root of u can also be written as u raised to 1/2. And applying the seventh formula, this should be equal to, copy the base 1/2, or bring down the exponent rather, 1/2, copy the base u. The exponent would be 1/2 minus 1, or the exponent minus 1 and minus 1, times the derivative of the base with respect to x. And the new exponent now (1/2 minus 1/2). 1/2 minus 1. Just copy the constant, the base, and the new exponent is negative 1/2 du over dx. If the exponent is negative, you can write it as a reciprocal and then changing the exponent to positive. Du over dx. This is now equal to 1 over 2 times 1 over the square root of u, because u raised to 1/2 is equal to the square root of u. Derivative of u with respect to x, or simply derivative of u with respect to x divided by 2 square root of u. That is the formula for a square root. Remember, just as a recall, we have u raised to 2/3. You can write this as u, copy the numerator 2, and then cube root. Okay? And u raised to negative 2 can be written as the reciprocal of u raised to positive 2. So, in general terms, u raised to m over n, where m and n are constant values, is equal to u raised to m and the nth root of this function. And u raised to negative n is equal to 1 over u raised to n. Okay, let's continue. Let us now have some examples. So, number 1, y is equal to x squared plus 3. So let us find y prime, or derivative of y with respect to x. So applying the concepts that we have learned, derivative of y with respect to x is equal to, using the second formula that I introduced you can say this is equal to derivative of, or let's just write first, derivative of x squared plus 3 with respect to x. This can be written as the derivative of x squared with respect to x, copy this one, the positive, times the derivative plus the derivative of the constant 3 with respect to x. Now we can apply the power formula for this part, the derivative of x squared with respect to x. Bring down the exponent to, copy the base x. The exponent will be 2 minus 1. And then the derivative of the base with respect to x. This is for the first part. And last, the derivative of the constant 3 with respect to the variable x is equal to 0. So simplifying, derivative of x with respect to x is just simply equal to 1. So we can say that the derivative of y with respect to x or y prime is simply equal to 2x raised to 1 or simply 2x multiplied by 1, it will remain as 2x. This is your y prime. Another example would be y is equal to x raised to 3 plus five x plus 1. So we're looking for y prime again, the derivative of y with respect to x. This is y prime, derivative of y with respect to x, derivative of x raised to 3 with respect to x plus derivative of 5 x with respect to x plus the derivative of 1 with respect to, of course, x. So this is equal to our formula. Bring down the exponent, copy the base. The new exponent would be 3 minus 1 times the derivative of the base. This is your base, x with respect to x plus, using the formula, this is equal to 5 times the derivative of x with respect to x plus the derivative of a constant with respect to a variable is equal to 0. dx over dx is just 1. Same with this part. So what is left is y prime is equal to 3x raised to 2 plus 5 times 1 is equal to 5. Your first derivative with respect of y with respect to x. Some another example, number 3. Let's say y is equal to 3x, the whole quantity raised to 4. We can apply the power formula for this one. For y prime, that is, bring down the exponent, 4, copy the base. The base this time is 3x because that is inside the parenthesis. Take note that 3x, the quantity raised to 4, is not equal with 3x raised to 4. They are not equal. For this one, 3 is also raised to 4. But for this part, 3 is outside the parenthesis, and that is outside the exponent. So, x is the only one being squared, or being raised to 4. So for this one, bring down the exponent, copy the base. Your base is 3x. Your exponent is 4 minus 1. It should be 3. And the derivative of your base is 3x. With respect to x, of course. Simplifying, we have 4. 3 raised to 3 is 3 times 3 is 9. 9 times 3 is 27. This is 27 times x raised to 3. And for this part, the derivative of 3x with respect to x, we can write this as 3 derivative of x with respect to x. This will cancel to 1. 3 times 1 is simply 3. So this would be 4 times 3 is 12 times 27 times x raised to 3. Let me use my calculator. 12 times 27. It should be 324. This is equal to 324 times x raised to 3. This is your y prime. Take note of your base if you are seeing these kinds of problem. Now what if we have our example for y is equal to 3x raised to 4. This time, the variable x is only the one being raised to 4. So for y prime, this is equal to 3 times the derivative of x raised to 4 with respect to x. So y prime is equal to 3 should be go back. Okay, it should be the derivative of x raised to 4 with respect to x. Bring down the exponent, copy the base. The new exponent would be 4 minus 1 or 3 multiplied by the derivative of the base. The base here is x with respect to respect to x. So again, derivative of x with respect to x is simply equal to 1. We are left with this value. The constant 3 times the constant 4 is equal to 12 times the x raised to 3. That is your first derivative. For the fifth example, let's try to have something harder. But if you have x is equal to t raised to 3 times t raised to 5. But there are two solutions for this one. The first one, say solution 1. This time we are looking for the derivative of x with respect to t. And this is not equal to what? Not equal to x prime. So x prime is equal to derivative of x with respect to y. We only have a designation for the primes of x and y because we are using it in the application. Basically, that would be used in finding the slopes of curves at a given point. X prime and y prime are used. And we don't use any other designation for other variables. That is simply for the ease of writing it. It's understood that x prime is equal to the derivative of x with respect to y, and y prime is equal to the derivative of y with respect to x. Continuing, we are looking for the derivative of x with respect to t. So derivative of x with respect to t. Let's make this solution 1. We can use the product formula. And for the product formula, we will copy the first part, the first function, t raised to 3 times the derivative of the second part. This would be derivative of t raised to 5, of course with respect to t. Plus, because that is multiplication, this time the second part, t raised to 5 times the derivative of t raised to 3 with respect to t. So simplifying, we have this t raised to 3. The derivative of t raised to 5 with respect to t is simply equal to, bring down the exponent, copy the base, and the new exponent would be 5 minus 1 or 4 times the derivative of the base t with respect to t is simply equal to 1, so we will not write it anymore. But for your seatbelt, I want you to write it so that you will not forget the properties for your thesis and your exams. Okay, so copy t raised to 5. This would be the derivative of t raised to 3 with respect to t. Bring down the exponent 3, copy the base t. The new exponent would be 3 minus 1 or 2, and multiply by the derivative of the base t with respect to t is simply 1. I'll just write 1 here so that we will not forget it. Okay, continuing, we have derivative of x with respect to t is equal to t raised to 3 times 5 times t raised to 4 plus t raised to 5 times 3 t squared would be squared if you will recall, we have a variable a raised to n, an exponent, and if you will multiply that by the same variable a raised to a different exponent, this is simply equal to a raised to m plus n. This is a review of the asserts or exponents, and you should know that because we will not be tackling these basic concepts. This is already calculus. You should know it by now from your algebra. Okay, so we will apply this property in our derivative. So let's just copy the constant t raised to 3 times t raised to 4 plus copy the constant here 3 t raised to 5 times t raised to 2. We will continue. This is equal to 5 t raised to 3 plus 4 is 7 plus 3 times t. 5 plus 2 is 7. If you have the same base and same exponent, you can simply add its coefficient and copy the base and the exponent. This is equal to 8t raised to 7 because of this 5 plus 3, 8, and copy these functions because they are the same. We can copy it and we can add them. This is equal to derivative of x with respect to t. But we have our solution 2 for this one. I just demonstrated it for the sake of demonstration. The problem is t raised to 3 times t raised to 5. Let's just rewrite it here. X is equal to t raised to 3, t raised to 5. We can immediately perform simplification before taking the derivative. So this is x. We have the same base, t, different exponent, we can add them. So this is equal to 8. And then, now we are ready to take the derivative of x with respect to the variable t. And this is equal to, bring down the exponent 8, copy the base t, and the exponent would be, new exponent would be 8 minus 1 or 7. This is the same with our first answer, 8 times t raised to 7. So if you can simplify it right away, before taking the derivative, that would be easier. So I just showed you this one for you to appreciate the concept of simplification prior to taking the derivative of these functions. That's our 5th example. Let's continue with our 6th example. So let me just make my problem. Say we have y is equal to x squared multiplied by x plus 1 raised to 3. We are looking for y prime. So this would be y prime, derivative of y with respect to x. And this is again a product of two functions. So derivative of x squared times x plus 1 quantity raised to 3 with respect to x. So for the product, this is a product. Copy the first term times the derivative of the second term x plus 1 raised to 3 divided by x plus the second term, x plus 1 raised to 3 times the derivative of the first term, x squared, with respect to x, which is equal to x squared. We can apply the power formula here. Bring down the exponent. Copy the base, x plus 1. Your new exponent would be 3 minus 1, that would be equal to 2. Times the derivative of x plus 1, or the base, with respect to x. That is for the first part. Plus, for the second part, copy x plus 1 plus 1. This is raised to 3. We are just copying it. Times the derivative of this function. Bring down the exponent 2. Copy the base. This is raised to 1 times the derivative of x of the base with respect to x. That is simply 1. Continuing, we have here simplification, x squared times 3 to 3x squared times x plus 1 the derivative of x plus 1 can be written as derivative of x with respect to x plus the derivative of the constant 1 with respect to x. Don't forget for parentheses. This is equal to 1 and this is equal to 0. So basically, is it 1 plus 0 is 1. 1 times this value is equal to 3x squared times x plus 1 x plus 1 is equal to times 1. So it will be the same. Don't forget the second part here. X plus 1. Don't forget the exponent 3. And this would be 2x raised to 1. Or simply 2x multiplied by 1 is just 2x. So we add here. Plus 2x times x plus 1 raised to x raised to 3. Okay. Let's simplify. Notice that you can factor out x. And you can also factor out x plus 1 raised to 2. If you factor that out, factor out x here and x plus 1 raised to 2. Ang matitira ay, what is left would be 3 times x. And then for this one, you factored out x and x plus 1 raised to 2. What will be left is x times x plus 1 raised to 1. To check whether your factoring is correct, you can multiply this back, distribute it back, and you should arrive with the equation at the top. This is y prime, by the way. So y prime is equal to x times x plus 1 quantity raised to 2 is equal to 3x plus distribute 2. This is 2 times x is 2x plus 2 times 1 is 2. So what is left is x times x plus 1 raised to 2 This would be 3x plus 2x is equal to 5x. And you add the constant 2. Don't forget to include them both inside the parentheses. That is the simplest form of your answer, y prime. For your quizzes and other activities in your exam, I want you to write it in the simplest form. This is y prime. Your answer should always be in the simplest possible form. So you should review your algebra and the properties of your algebra and other operations for you to be able to answer this correctly. So I think that is our 6th example. Let's now move to the 7th example. 7th example would be y is equal to 3x squared over 2x. This is division, so we can apply the derivative for division. We are looking for y prime. This is equal to y prime. Okay. Copy the denominator. This should be 2x times the derivative of the numerator, 3x squared with respect to, of course, x for the first part, minus 3x squared times the derivative of your denominator, 2x, with respect to x. This would be equal to 2x, or forgot something. Should not forget the denominator for the derivative. Copy the denominator, and that should be raised to 2. The denominator, the whole denominator should be raised to 2. This is equal to 2x. The derivative of 3x squared is simply copy the constant, and the derivative of x squared with respect to x is bring down the exponent, copy the base. New exponent would be 2 minus 1 or 1 times the derivative of the base. X with respect to x should be 1 minus 3x squared times the derivative of 2x with respect to x, copy the constant 2. Derivative of x with respect to x is simply 1, and we will divide this whole expression by 2x squared, or simply erase this one. It should be 2x, the quantity raised to 2. Simplifying, we have 2 times 3 times 2 is 6 times 2, 12. X times x is x squared, minus 3 times 2 times 1 is 6 times x squared. Divide this by 2x raised to 2. You should be, take note that 2 is inside the parenthesis, and that whole expression is divided by or raised to 2. So this will be 2 raised to 2 is 4, and x raised to 2 is x squared. Simplifying, you will have 12x squared minus 6x squared is equal to 6x squared. Divide this by 4x squared. This is equal to 6 divided by 4 multiplied by x squared over x squared, and these two, x squared divided by x squared, or the value divided by itself, is simply equal to 1. So 6 divided by 4 times 1, your derivative of y with respect to x, or y prime, is simply equal to 6 divided by 4. This can further be simplified into 3 over 2. That is your y prime. But if you will notice, you can simplify right away before taking the derivative. I'll just copy the problem. Y is equal to 3x squared divided by 2x. To simplify this, you will cancel one part or 1x, because you can write it as 3x times x. This one. Should be 3x times x divided by 2 times x. So we can write this as 3 over 2 times x multiplied by x over x. And again, this will cancel to 1, leaving you with 3 over 2 x. You can now take y prime, and this is equal to, copy the constant or the coefficient times the derivative of x with respect to x, this is simply equal to 1. So you will have y prime equal to 3 over 2. So as always, it is always easier to simplify first before taking the derivative of the function. Let me look for other let's try this one. I think this should be our last example. X is equal to 2 divided by, let me make my own problem, 1 minus s squared, let's say. Okay, we're looking for the derivative of x with respect to the variable s, and this is equal to, remember this is a quotient, so copy the denominator 1 minus s squared, and then take the derivative of the numerator, that is 2, with respect to s. And since that is division, should be minus the numerator times the derivative of the denominator 1 minus s squared with respect to, of course, s. Don't forget, all of these should be divided by the denominator 1 minus s squared. The quantity should be squared. Okay? Continuing. Let's have this problem. The derivative of a constant with respect to this variable is equal to 0. So 0 times 1 minus s squared is simply 0, leaving us with negative 2 times the derivative of 1 with respect to s. Minus the derivative of s squared with respect to s. And it should be divided by 1 minus s squared quantity squared. Continuing, we have negative 2. Derivative of a constant with respect to a variable. S is 0. So this should be multiplied by negative. So this exponent, bring down the exponent to copy the base s raised to 1, and the derivative of the base s with respect to s is equal to 1, simply 1. This is divided by 1 minus s squared quantity squared. And then further simplifying, we will have negative 2 times negative 2 is positive 4 times s raised to 1, or simply s, divided by 1 minus s squared, the whole quantity squared. So this is the derivative of x with respect to s. So I think that would be enough as examples for the derivative of algebraic functions. You